So everything you do for this lab is going to be step by step in the lab manual, starting on pages, I believe it starts on page 88. And it's just, if you don't have Google Earth, if you haven't downloaded it, you are going to have to download it to computer, because the free one, well, it's free to download it, but the one just online won't have the program you would need. So it's really quick to download. If you need to, just go ahead and download it now. And by the time we're done with the 2 videos, you should already have it downloaded. But the way this lab is going to work is, if you want to do this on your own time, that's fine. You'll just have to take scans of each page and send it to me, and I'll look at everything. But if you just want to do it tonight and then you'll know you just get 100%, what you'll do is you'll go through the whole exercise, and then when you're done, just send me a message in the chat, and I'll pick a couple random questions, and you'll just send me the answers for those. And once you do that, you'll get 100%, and then that's all you have to do for this week. You won't have to worry about it or turn anything else in. You'll have turned in everything for the lab section. So that's really up to you. I would suggest just staying online and doing it. It's a lot quicker, and then you don't have to worry about it for finals week or anything else. But I will leave that up to you. Otherwise, just take scans and then email them to me, and I'll look at them. And then also, I will try to get all of your grades in by this Friday. If either way, if I get them done or if I do not, I will send an announcement to give you an update. But I will hopefully get those to you before finals next week. So let's go ahead and get started on the material. These are just energy units. We've used a couple of them, but not many. You are probably familiar with a good bit of them, especially if you pay your own electric or if you've seen electric bills. But these are just kind of some sample energy units that we use in the energy sector. The main one is going to be joules, used in science. That's your SI unit. Water, here, let me move this out of the way. So this is just water withdrawal. This just shows how many thousands of gallons of water is used to produce 1 megawatt hour of electricity. You have nuclear, concentrated solar, coal, biomass, natural gas, geothermal, solar, photovoltaic, and wind. We're going to be looking at wind, coal, and solar. So that's what we're going to be looking at. Nuclear is all over the chart. Obviously, nuclear can use a lot to take water to cool the reactors in some of these giant plants. So that's why it's all over the place. And then coal, it just depends on the type of mining, how much water it will use. The rest are generally pretty efficient. This is going to be CO2 emissions by source. Coal is obviously the absolute most, followed by natural gas, and then geothermal energies is down here. But coal is because you're just burning fossil fuels. Same thing with petroleum down here, and natural gas. These are jobs created per gigawatt hour of energy. Each box is one job. Solar obviously creates the most amount of jobs per gigawatt hour. Coal is down here. It's maybe 1/10 of a job. Wind is right here, maybe about a half. And then for the jobs in each sector, these are the salaries, and this is in increments of $20,000. These little circle dots are the medians, and then the ranges are the middle 50% of values. So it cuts off the upper and lower halves to just show you kind of the median ranges. And then obviously as the jobs get more dangerous, you have a higher pay so that people will actually do those jobs. And then these are the costs to produce the amount of energy. So as you can see, coal actually takes a lot of money to produce the energy. It's not extremely economically efficient. Wind, it can vary, natural gas, and then solar as well. We'll kind of talk about why these would vary, and it just depends on how much is available. And if you put it in a high available area, it could be very cost effective. So the first video we're going to watch is mountaintop removal. And this is going to be the type of coal mining that we will be focusing on today and looking at the destructive impacts. So let me share that with you so you can see it. Let me know if you cannot hear it.
It's environmental rape. It's environmental rape. That's all you can call it. They've just destroyed our way of life completely. Everything that the mountains meant to us has been destroyed. Since this land got disturbed by the coal and timber companies, we don't have hardly anything left.
Just southwest of our nation's capital, one of the greatest human rights and environmental tragedies in American history is taking place at this very moment. Mountaintop removal is a form of coal mining that's designed from the start to take the coal miner out of coal mining. The companies use explosives to blow up the tops of the mountains, and they dump the rock into the valleys, totally burying the streams. What's left behind is a moonscape.
When you're blowing up, literally blowing off the top of a mountain in order to get at the coal, and all of the debris and everything else, the whole top of the mountain goes down in the valley, dams up rivers, affects communities. I mean, it's just wrong. It's just wrong. It's so deeply wrong that we have to do something about it.
When they level the mountains, they have to have something to do with everything other than the coal. The leftover debris is put into the headwaters of the hollow, and it changed the velocity and the volume of water that comes through my property here. And we've always had a small stream run through here. It's named Big Branch Creek. It's always been a little tiny stream though. And through the manipulations of the headwaters of the stream, I've been flooded now 7 times. In 2001, the bridge washed out, and we repaired it, and then it washed out again. So I lost 2 bridges. And at this point, we have no access.
My son called and he said, "Dad," he said, "if you're getting home, you better come on." He said, "It's starting to flood up here." So we got down to the mouth of the hollow, and this 15-year-old boy met us, and he said, "You can't get up the holler." He said, "It's flooded." In a matter of an hour, this 15-year-old boy was drowned. And with him, his neighbor, a 35-year-old lady, they stepped across a little ditch going into their yard that normally was 6 or 8 inches deep, and they were swept away. We spent the night together, all of us huddled around in this house, and it was a night of unbelievable sorrow.
This isn't just a regional issue, because people from all across America use electricity that's at least partly generated by mountaintop removal coal, but it's a small amount that could easily come from cleaner sources of energy.
Instead of going under the mountain and getting the coal, they just take the mountain off of the coal, and they scoop out all that coal in that seam, and they go on down to the next seam and push all the overburden over the mountains into the valleys, and they get that seam. And as I said, there's 8 or 9 seams here they got, and each time it's more dirt and rock come down over the valleys. They say it's more economical. They take a handful of men with equipment and accomplish in a matter of months what an underground mine would take years with a lot of men to do.
It's providing cheaper energy for our society, cheaper costs, big profits for coal companies, a few people are getting jobs, but it's a one-shot deal. And those mountains and those streams are not going to really recover. And it's breaking covenant with God and creation.
The streams that go by me here right now are the headwaters of the streams all over the eastern United States. And whether people realize it or not, everyone's downstream from this. The planet shares water, you know, and if there's one drop of it polluted, then all of it's polluted.
All of this is happening in a region that's a national treasure, home to bluegrass music and the Blue Ridge Mountains, and it's also home to more species of plants and animals than almost anywhere else on Earth outside of the tropical rainforest.
It's the worst thing that has ever happened to this state. And it's not even being discussed in the political debates. I'm here to mourn the stupidity and ignorance that says coal is West Virginia. West Virginia is mountains. West Virginia is not coal.
Coal fields, as they're called sometimes, the southern Appalachians, some of the poorer areas in the country, and yet some of the greatest wealth has been extracted. There's something wrong.
To know that me and my children have been sacrificed for the wealth and riches of other people is very frustrating. But at the same time, I have to direct my anger and do something about it so that my children have a possibility of a future.
It's a national sacrifice, and as I see it, in a sense, a cultural and economic theft, at least a con that they're trying to perpetuate.
It has to change, and it will change on an individual basis. Everybody has to stand up and fight it.
Everybody coming together and voicing their concern together, actually a communal effort really is what it is. Through Appalachian Voices can make a difference and will make a difference in this fight. But it's definitely going to take a concerted effort.
Growing up in East Tennessee, I thought the mountains would be there forever. But in my lifetime, more than 450 mountains have already been destroyed. And if we don't act, hundreds more mountains will be lost forever. To stop this, we have to remove the cloak of secrecy that's allowed it to go on. And that's why we created ilovemountains.org. Thanks to new technologies like Google Earth, the coal companies can no longer hide the massive scale of destruction that they're causing. Together, we can meet America's energy needs and protect our nation's natural and cultural heritage. But it won't happen without you. Please help us spread the word. And thank you.
How many years can a mountain exist before it's washed to the sea? How many...
All right, so that's mountaintop removal. The video does a good job of addressing the issue. It basically, they just use explosives to blow off the top of the mountain so that they can get to the coal underneath it. It's a lot cheaper and you need less men to do it. One of the problems from that they touched on is mining creates a lot of toxic mine waste, and all they do on the mountaintops is they make little retention ponds and they just stuff it in that, and it usually has dirt, sometimes concrete barriers and walls. Those will break every once in a while, and then you just have kind of like a flash flooding event of this extremely toxic water waste, and often where it touches can't grow because it's so concentrated in heavy metals. And then that's the coal mining that we'll be looking at. You'll look at a couple different mountaintops and then measure the areas affected, and then there is one where I believe you'll see a sludge pond. So I'll go over exactly how to do that once we get through this PowerPoint. But the next energy source we're going to be looking at is the first renewable one. It's going to be wind. So this map right here just kind of shows where in the US is most optimal to place wind farms. And these, if you look at the legend over here, the reds, blues, and purples are the most optimal places where you're going to get to generate the most wind. If you place a wind farm here, say in Nebraska or Kansas or the Dakotas, you're going to get a lot more energy if you were to place it in Georgia or Florida. And that's mostly because this is mostly flat land, and then off the coasts, you have a lot of wind that does not get slowed down or obstructed by anything. So we'll watch another quick video just about wind. This one's a lot more humorous than the last one.
I'm always walking to the same old.
There's a quick ad. Once again, let me know if you can't hear this one.
But I'll be okay, 'cause in my dream world, I'm still your dream girl. Ooh, I'm still your dream girl.
All right, so that's just a quick little look at what the hell? Okay, so that was just a look at wind. I don't believe they actually ever were able to build the wind farm at Cape Wind. But this is a big thing that people bring up, is that wind power is detrimental to birds. And this is just the estimated mortality of birds, and millions of birds. Wind turbines is here. As you can see, doesn't really affect them at all. It was the case back when they first started making solar farms. They had smaller turbines that spun faster, but now they've made big giant turbines that spin a lot slower, and they're easier to see for the birds, so it's not really much of an issue. And then the next thing we're going to talk about is solar. This is the same kind of map that we looked at earlier for wind power, just this is now for solar. Darker colors mean that you can generate more solar energy, and as you can see, this is mostly in the desert part of the country is where you're going to be able to generate the most, and then Hawaii has a good bit as well that we can generate. So you're going to find a lot of solar farms here, and I believe the solar farms we look at are in Nevada, but I'm not positive. And that is really it for that. So now we're just going to get into the actual assignment. So if you open up Google Earth, so this is Google Earth. This is just going to be what comes up when you first open it up. Over here, if you don't see your layers, it'll be down here. You need to open those up. You might have things clicked. Go ahead and unclick all those. It'll make it run a lot faster, and it'll be a little cleaner look. Okay. And then, so right here, this global awareness layer, if you click that, the very first one is going to be this Appalachian mountaintop removal. You'll just want to turn that on. And then you'll be able to see all of these are going to be mountaintops that were affected. This starts on page 88 in your lab manual. It just has some data for you. So the first one we're going to be looking at is Mud River, West Virginia. I'll go over the first one with you just to show you kind of how you're supposed to do it. So you can find it on here. I'm not quite sure which one it is. It's West Virginia, so it's got to be up here. But it's a lot easier if you have the coordinates in bold in your lab manual. So if you just type those in this search bar up here, hit enter, it'll bring you exactly to the search area you're supposed to be looking for. And then so it obviously zooms in a lot. You'll just have to zoom out until you see this yellow square. This yellow square is going to be your search area. And then it wants you to approximate the area of cleared land within the yellow polygon. So just like the rivers, you're going to want to use this ruler tool up here. And you can do polygon. And what you're going to want to do is you're just going to want to click around the shape. You don't have to, if you want to do it real accurate, you can, but as long as you get it close to the shape, that's fine. And then obviously don't use centimeters, use kilometers, please, or meters. Either one's fine. And then you're just going to write your answers for that. And then you're just going to want to follow the instructions for, like, this would obviously be your yellow polygon. It's going to want you to find additional areas. So as you can, for this example, it's pretty obvious which areas are cleared and which are not. If it doesn't have trees on it, except for these roads, then it's obviously been cleared. So your additional areas are going to be within this polygon. This is obviously one, and then there's two other that are pretty distinct. But if you can't find them, just let me know and I'll help you. And then you're just going to want to go through each example for the mountains. And then just for the sake of recording, I'm going to go over the solar power real quick and the wind, but I can obviously go back and do those again. So if you want to follow along and just watch right now, or if you want to just continue on the mountains, that's up to you. So this is going to be a solar farm. All of these are solar panels. It just wants you to look at the cleared land. So you're going to want to use this solar panel area. These are all solar panels as well. So you can either do it, when you do your polygon, you can either do 3 separate polygons and add them together, or you can just do kind of like as best as you can to get as little of everything else in. So say you just trace all around that. And then you can just kind of mitigate it like that. So that's all you're going to do for the solar panels. They're pretty easy to see as they don't look anything like the rest of the land, whereas wind power makes it a little harder to find. I'll go over that real quick. So wind farms are a lot more spread out, and sometimes the turbines are a lot harder to see. Like, so these rows are all wind turbines, I believe. Actually, that's right. These are all, if you zoom in, these are all capped. It's not in the correct spot. So the wind turbines you're going to be dealing with are going to be below this highway. This used to be where they were, but they put in newer, bigger ones. So it's easiest to see these wind turbines since you're looking at them from the top. They don't look like much, but if you use the shadows, you can kind of go around and see exactly where all these turbines are. And they're pretty spread out for this one. The other one, I'll pull it up real quick. I believe it isn't as so those ones I think. All right. Yeah, so these ones are a lot more concentric rows, but they cover a lot bigger area. So it's on this side of the road. These are all wind turbines. So you just kind of have to search around and do your best approximation when you're doing your polygon measurements. So you'll go through the 3 or 4 pages, and then on the very last page, 93, it has a table that it wants you to fill out, and you're going to have to put your areas, and then you're going to rank mountaintop mining, solar, and wind practices as the degree of ecological impact. And when you look at the ecological impact, don't just look at the complete area that has been changed, and it wants you to do it in kilometers. So go ahead and make sure all your measurements are in kilometers so you can easily fill out the table. But when you look at the ecological impact, don't just look at how much of the area is transformed, look at how the area is transformed. Mountaintop, obviously, they called it moonscapes just because nothing really grows there and it just looks like you're on the moon because nothing's growing there and it's just barren dirt. Solar, it has these giant wind farms, and then you really only can do, or not, giant solar farms of just stacks and stacks of panels, and you can really only use that land for one purpose. And then as you can see, for wind farms, they're a lot more spread out, and while they do affect a lot of area, they don't change the area as drastically as definitely as mountaintop mining. And you'll just have to kind of make the determination of which one, solar or wind, impacts the earth as much. So that's really all we're going to be doing today. We're just going to be running through those. One last thing, since this is the last class, we will not be meeting next week. They are the surveys that are available online just for this course. I suggest you take them. You be as brutally honest as if you like the class, write that. If you didn't, write that as well. It's just so we can better change this for next semester and evaluate how I did teaching. I know this semester was not normal, but I appreciate you guys doing the best you could with all the changes, and hopefully you learned something, even though we weren't able to do hands-on labs and actually do the experiments. You didn't really get to do that part, but hopefully you still are taking something away from the class.